Hello, in this video we're going to introduce the metric system for our unit. So what is the metric system? It's a system that comprises of unit measurements. These measurements are meter for length, gram for weight and mass, volume or capacity for liter, and then temperature is degrees in Celsius. Please note that the metric system is in base 10 system and it is used as a standard for science fields in most of the world. How much of that world? Every country that is in light blue has officially adopted the metric system and is used for everyday measurements across the country. The purple we have the metric system, but we measure primarily in the imperial system. Red, which is right here, and right here, these little countries right there, they have officially on the imperial system, but they both use metric and imperial. And then right here, as you can see, is mixed. But the majority of the world uses a metric system. In the sciences, we use the metric system just so that we are measuring across the board. So if someone is doing an experiment in America, you can use the same type of measurements in the UK or India, and that way we can compare results on the same ground. So let's first talk about the meter. What is about the length of a meter? A meter can be about the height of a 3-year-old, depending on how tall they are, the length of a guitar, or height of counters. In our imperial system, a meter is approximately 39 inches, or approximately 3.28 feet. The label for the meter is just using the letter M. What is the weight of a gram? A gram is about the size or the weight of a paper clip, the weight of a pen cap, or even a weight of a dollar note. A gram is a very small measurement. It is 0.0022 pounds, or, oh, I guess I forgot to finish the ounces. Let's see, what's 6? Let's see, let's quickly do some math. So there are 16 ounces in a pound. Let's do 16 times, let me use this pen. Let's do, it's a different color. 16 times that 0.0022. Using a calculator, we find that we get 16 times 0.0022. The number of ounces is 0.0352, which isn't a lot. The label for gram is the letter lowercase g. The liter is what we use to measure capacity, volume, liquid volume, essentially. What is about that size? It's about a half of a large soda bottle. It's 1/4 of a gallon of milk. It's about 4.323 cups of coffee, so long as that cups of coffee is 8 ounces. A liter is approximately 33.81 fluid ounces. The label for liter is capital L. So notice that with meter and gram, the label is lowercase while liter is uppercase. So let's go ahead and practice a little bit. What we want to determine is which is the best measurement or most reasonable and appropriate measurement for the situation. Take a time to pause the video and answer the question and determine, based on the description, what would be the most appropriate, meter, liter, or gram. Okay, hopefully you've paused the video and taken some time to practice some of the problems. Let's look at the answers. Problem or situation number 4, number 6, and number 7 is considered meter because they're all distances or heights or weights or some sort of length. Meter is always going to be with the length. Liter is going to be 1, 3, and 8. Notice those all have capacities of amount of a liquid, amount of water, amount of gasoline, amount of soda. And then finally 2 and 5 are grams. They both talk about weights. So in the imperial system, we'd use pounds as weight. In the metric system, they use grams. Or grams are used. Now the biggest thing about the metric system is that it is a base 10 system. Because this is base 10, that means every position can be moved by a power of 10. To help determine which power of 10 is being used, we use prefixes. These prefixes are used for either meter or liter or gram. So we'll find. The most common ones that we are going to use are going to be kilogram all the way to milli. So on the paper, or on the slide, that would be kilo to milli. But notice that we have exponentially large and exponentially small. But in everyday usage, these are the ones you're going to look at. We're going to use the most. Kilo, hecto, deca. No prefix name because that's your base. So that prefix for that one, or it wouldn't be a prefix, it would just be meter or liter or gram. For example, if I had meter, but then I had 1,000 meters, that's the same as a 1 kilometer. Just like in our base 10 system where we have 10 tens is actually 100, 1,000 meters is going to be 1 kilometer. You'll notice also that there's a symbol. That symbol will go in front of your symbol for your base unit. So for example, if you had kilograms, you would have kg, so it's a kilogram. If you have a deciliter, then it'd be D capital L. Okay. You should know the conversions for milliliter or from milli to kiloliter to kilo. You should know those. The other ones are extra, and if you were to go into the sciences or go into more scientific research or something that's you want to measure something really large or really small, those are used. But for everyday usage, we focus on milliliter all the way to, or from milli to kilo. So now let's practice. Let's use the prefixes and base 10 to find the conversions. The first one we're going to look at is the conversion for 158 hectometers to meters. So meters is the base. The prefix is hecto. Now if you remember from the previous chart, if meter is my base, then we had decameter and we had hectometer. What we're doing is we are taking a larger measurement. We're going from hecto and we're going 2 meters. Or we're going from hectometers to meters. What we're doing is we're going from a larger unit of measurement to a smaller unit of measurement. In other words, it takes more meters to come up with a hectometer because a hectometer is 100 meters. So what we're going to do is we're going to essentially move that decimal point where it was originally 158. We're going to then multiply that by 10 squared, which will give us 158.00 meters. Notice how we went to the right on the chart and we went 2 to the right here. What if we want to do centigrams to grams? So C is centigrams, then we have D, which is deci, and then we have G, which are base. This time, we're going from a smaller measurement unit to a larger measurement unit, which means I need less of the larger to get the bigger unit. So this time we'll take our 12.3, and this time we're going to multiply by 10, still base 10, but to the -2s because we're going to the left. This is the same as 0.123 gram. Again, there's more, since there's 100 centigrams in a gram, it makes sense that there are less grams in terms of numerical value than there would be when they had the centigrams. But please note that these measurements, the 12.3 centigram and the 0.123 gram, is the same amount, just represented differently. And then finally we have 160 decameters to kilometers. So we have meter as our base, then we have decameter, then we have hectometer, and then we have kilometer. We're starting at the decameter and we're going to kilometer. So the question is, we're going to take our 160, what are we going to multiply by? Hopefully you said -2 because we're going from a smaller unit of measurement to a larger one, which means it takes less of that same unit to make the same amount. And then we have the label of km.